Ever wondered what happens between pumping gas and your car actually moving? It's not magic. It's a beautifully engineered system. And today, we're diving deep into how your car's fuel system really works. Let's pop the hood and get started. So, you're at the gas station. You fill up your tank, and that's where our journey begins. The fuel tank, usually located at the rear of the car, is more than just a bucket. It has a vent system to handle pressure changes, an ascending unit that tells your dashboard fuel gauge how full it is. Inside this tank lives a crucial component to fuel pump. In most modern cars, this is an electric pump submerged in the fuel. Why submerged? Well, the gasoline actually helps cool the pump motor, preventing it from overheating. When you turn the key, this pump whirs to life, pressurizing the fuel and sending it on its way through the fuel lines. These lines are like the arteries of the system, running the length of the car from the tank all the way to the engine bay. Along this path, the fuel encounters its first gatekeeper, the fuel filter. Think of this as the bouncer for your engine. Its job is to catch any dirt, rust, or debris that might have found its way into the tank. A clean filter is essential, because even tiny particles can clog up the delicate components up ahead. A clogged filter can starve your engine of fuel, leading to poor performance, hesitation, and trouble starting. After passing through the filter, the clean, pressurized fuel arrives at the engine and reaches the fuel rail. The fuel rail is a pipe that distributes fuel to each of the fuel injectors, one for each cylinder of your engine. And this is where the real precision happens. The fuel injectors are high-tech, electronically controlled nozzles. Your car's computer, the engine control unit or ECU, is the brain of the operation. It takes in data from dozens of sensors like how much air is entering the engine's temperature, and how far you're pressing the gas pedal. Based on all this information, the ECU calculates the exact amount of fuel needed for that split second. The ECU then sends an electrical pulse to each injector, telling it exactly when to open and for how long. We're talking milliseconds here. The injector opens, and a fine, atomized mist of gasoline is sprayed directly into the intake port, just before the intake valve. This fine mist is key because it mixes much more efficiently with the incoming air, creating a perfectly combustible air-fuel mixture. This mixture is then drawn into the cylinder as the piston moves down, compressed as the piston moves up, and then ignited by the spark plug. Boom! The explosion pushes the piston back down, creating the power that turns your wheels and makes your car go. It's a continuous, incredibly fast cycle, happening thousands of times per minute. What about unused fuel? Well, some systems have a fuel pressure regulator that sends excess fuel back to the tank through a return line, ensuring the pressure in the rails stays constant. However, many newer cars have returnless systems where the pump speed is varied to deliver only the amount of fuel needed, which is even more efficient. So, from the tank, through the pump, lines, and filter, to the injectors controlled by the ECU. It's a sophisticated dance of mechanics and electronics, all designed to deliver the right amount of fuel at the perfect time. Understanding this helps you appreciate the engineering under your hood and makes troubleshooting issues a lot easier. Next time you have a problem, you'll have a better idea of what might be going on. I hope this demystified the fuel system for you. If you found this helpful, give this video a thumbs up and hit that subscribe button for more deep dives into how your car works. Got any questions? Drop them in the comments below. Thanks for watching, and I'll see you in the next one.